Good morning, everybody. Welcome to Monday morning at Chem 11:05 with your host, me, Dr. White. I hope you all had a nice holiday weekend, whatever holiday you're celebrating. For me, it's Passover. Can't you tell all the matzo balls I've been eating? Anyways, let's get going. All right, one, let me remind you, henceforth, if you do not submit a lab or your test is a single PDF file, I will not grade it. I will give you 0 points. Again, henceforth, starting today, the 10th of April, 2023, if you do not submit your labs or your test as a single PDF file, I will not grade it. Don't forget, for labs, the ones indicated, like the one due this tomorrow, you need to have a picture included of you doing part of the lab. Now, speaking about that lab, I had an inquiry from one of your colleagues about activity 4. And there, it asks for you to do a visual representation of atomic radius, First ionization energy, and electronegativity. So how can you do that? Well, for electronegativity, for each row or atomic radius, I believe it goes this way, it gets larger. Let me check that. This is one I don't do that often. If you notice on the screen, it says on the periodic table, the atomic radius generally decreases as you move from left to right and increases as you move down the group. So what does that mean? I was wrong. Like I said, I don't use this one that often. So say for the first row, you have it bigger and smaller like this, and that would be a designation. And for the next one, it gets bigger and so on. Now, for the other two, you could do a bar graph. Now, if we look at electronegativity, for example, this way it gets larger. And when you go up, it gets larger. So you could do a bar graph like this. As you go, this would be larger across the periodic table for each row. And that's how you would do that for the lab that's due tomorrow, where it asks, prepare a visual presentation for graph, illustration, or model. And you do for these 3. Now, don't forget for this one, at least one of the activities have a picture of you with the deck of cards, or they're spread out. I don't care which. If you don't, you get 0 points. And I will not be going back and emailing you, say you forgot to do this. From now on, for labs, make sure you have a photograph when needed. 2, make sure it's a single PDF file that you can open so I can open. All right. Now, by now, all of you should have gotten the results in Blackboard for test number 2. And thank you, and everybody, thank you. The class average was quite good. You people are learning chemistry and moles. Thank you. Now, you should have also gotten an individual email from me for each one of you. That has the points for each answer on your test. Make sure you check it. Make sure if it's a 4-point problem and you did it all right, I gave you 4 points. You should never, ever be penalized for an error I make. If I make an error, email me and let me know about it. Oh, before we go over test 2 answers, I'd like to remind you about the lab amnesty program. If you're missing some labs, let me know. Boy, this is thirsty this morning. Let me know once you've uploaded the missing lab by email so I can go back and grade it. All right, where to go? Hold on. There you are. It's having a little computer problem here. Let's try this again. Now, a question. I just looked at the clock, see how am I doing? I'm doing pretty good. Now, the question I would have if I were in your shoes, I don't know if they fit, but oh, that was bad. Sorry. But anyways, what's this? Well, anyways, it's Goofy Monday after a holiday weekend. And holidays for some of us are still going on. All right. What grade are you now getting in my class? Good question. Let's take a look. 2 ways you can figure it. Now, both these methods assume you've handed in all the labs. Otherwise, it gets more complex. I'm not going to do that. You need to find out about that. Come to my office hours. All right, method 1. Take the sum of your two test scores, divide it by 2, and you'll get a number X. And if you look at this, and this is also my syllabus, if your grade is 90 and higher, right now you're getting A in my class, 80 to 89, B, 70 to 79, C, and 60, 69, D, and less than 60, 59 or less, you're getting an F. Now, this assumes you are handing in all the labs. And if you have, you probably did good on the lab. Now, there's another method, and that's method 2. And method 2 involves looking at your two tests, and whichever is the highest of the two scores, that's equal to Y. Just don't forget, you get to drop one test. And if Y is 90 or greater, you're getting an A. 80, 89, B, 70, 79, C, 60, 69, D, less than or equal to 59, F. And that's assuming, remember, both of these methods, 1 and 2, assumes that you've handed in all the labs. And that's how you'd find your grade. Now, let me remind you, hand in labs. They're easy points. The labs aren't that hard. If you need help with a lab, email me or come to my office hour. Or if you really need help, email me and I'll see if I can set up a private Zoom meeting for you. And we're caught up. Now, if I look at the clock, I think this would be a good time to take a 5-minute break. I'm going to take a 5-minute break and get up and stretch, get a fresh bottle of water so I can do the next hour of lecture. And I'll see you in 5 minutes. Welcome back. All right, let's continue on with gases. Last week, we talked about pressure. Now we're going to get into what's called the gas laws. Now, the gas laws are a group of laws that have mathematical formulas that show relationship between important properties of gases. Now, why do I have to learn about the gas laws? Well, they help change the world. Huh? Well, if you go back, and let's get to the internet. And if you look on your screen, let me make sure you can see that. You'll see the Industrial Revolution. And the Industrial Revolution was the transformation from creating goods with just your hands to using machines. And it's generally considered, as you see here, between 1760 and 1840. Now, originally, to get power for machines, they used things like water and a water wheel. And later on, see here, you have the steam engine, and now they've got other stuff which I don't want to talk about. And you see on your screen, the steam engine turned wheels of mechanized factory production. In other words, using steam. What is steam? Steam is this water in a gas form. Again, steam is this water in a gas form. And the steam engine, and then later on, you got a colic up there. Stay down. Later on, the steam engine was replaced by the gasoline engine. And both of those rely on a piston expanding and contracting by what force? A gas. So let's look at the gas laws. Bear with me while I'm closing some stuff. All right, we talked about pressure and we went through converting. We did stuff like this last week. All right, let's talk about the gas laws. The first one is Boyle's law. Right away, switches on, not for definition, but you'll see. Now, as stated, the volume of a sample of gas is inversely proportional to the pressure applied to the gas if temperature is kept constant. Huh? Well, what you really should know is Boyle's law is right here. P1 times V1 equals P2 times V2. Now, what does that mean? Well, as you've heard me say a number of times, I've cut down on the memorization in my test for this class. And if you look at important information, test number 3, which is coming up in a couple of weeks, so keep up. Here's Boyle's law. Now, it's P1 times V1 equals P2 times V2. This will be given to you. In the past, my students had to memorize this. I've cut way down, and you don't. Yay. I hope you're all saying that. And what's P1? The initial pressure. What's V1? The initial volume of the gas. What's P2? The final pressure. What's V2? The final volume. So Boyle's law is P1 times V1 equals P2 times V2. And you have to know how to use this. Well, let's take a look. Anywhere from 8 to 10 points, depending on my mood. Hang in there. All right, let's take a look at this. If a balloon contains nitrogen gas at 20 and you have 25.1 L, L is liters, which is a volume, and 655 torr, you know torr Remember, L is abbreviation for liters, which is volume, torr, mmHg, millimeters of mercury, and ATM are pressure units. So if a balloon contains nitrogen with 25.1 liters and 655 torr, then what happens to the volume if the pressure is reduced to 315 torr? Now, if you look at this, it only deals with a gas, and you have liters and torr. What are you trying to find? The pressure after you make a change. Oops, I have this wrong. Now I'll have it right. What is the volume when the pressure is reduced? So that's the final volume, V2. This is the volume after you do something, final volume. What are you given? You're given the initial volume right up here. That's V1. You're given the initial pressure. That's P1. and you're given the pressure after you make a change. That's P2. And if you notice right here, the only thing we're dealing with is a gas and volume and pressure. And immediately you should think of Boyle's law, P1 times V1 equals P2 times V2. In case you forgot, you can look at important information, test number 3, Boyle's law, P1 times V1 equals P2 times V2. And in case you forgot, it's given to you, P1 initial pressure, V1 initial volume, P2 final pressure, V2 final volume. So now this is the equation we use to find our answer. What's our answer? We're looking for V2. Oh no, it's not alone on one side. When you have two things multiplied by each other, A times B, how do you get rid of one of them? Well, you know, A divided by A equals 1. So if I divide this side by A, it'll cancel out. Whatever you do to one side, you have to do the other. So if I want V2 alone on one side, I have to get rid of P2. How do I do that? Divide by P2, because anything divided by itself equals the number 1. But whatever I do to one side, I have to do the other side of the equation. Therefore, P1 times V1, I also have to divide by P2. Now take a deep breath. We're doing some algebra. Take a deep breath. Relax. Take a deep breath. Let it out. Take a deep breath. Let it out. Stay relaxed. We'll do enough of these so you'll understand what's going on. Now, anything divided by itself is the number 1 cancels out. So now I can write V2 equals P1 times V1 over P2. Now, I'm going to do something I like to do. You don't have to. I'm going to just rewrite this. V2 equals P1 times V1 over P2. And now, since we took the time to look up or read the problem right here, what's V1? Or what's P1? Doesn't matter which or. And we look up here, it's 655 torque. Now, what's V1? 25.1 liters. What's P2? Well, we took that's the final pressure, and that's 315 torque. Now, before I pick up my calculator, before I'm going to look at what I have here. And I'm going to use, once again, not the way we've used it in the past, but I'm going to use my good buddy, my good friend, unit analysis. And notice in this equation, we have torque times liter divided by torque. We're just looking at the units. And remember, anything divided by itself equals number 1 cancels out. So torr divided by torr, and we're left with liters. So what do I am looking for? A volume. And liters is a volume. Now, I can pick up my calculator. 655 times 25.1 divided by 315. And my calculator gives me this number. I'll have to write it over here. That. Well, remember, when you're doing a multiplication division, you get the same number of significant figures in your answer as the number with the fewest significant figures. This is 3 significant figures, 3 significant figures, 3 significant figures. Oh, this is easy. And what's the lowest number of significant figures in a multiplication division there? 3. So I have to round this off to 3 significant figures. And I'll give you a couple seconds, try it first, and then I'll do it. Time's up. And if we look at this, keep the 5, keep the 2, keep the 1, that's our 3 significant figures. Use the 9 to round off. Is that 4 or higher, less, or 5 or higher? And 5 or more. So I'm going to drop these numbers and increase this by 1. Which gives us 5.22 times 10 to the first power liter. And so when you reduce the pressure, the volume increases. That's 52.2 liters if you convert it back to decimal. So this is the ideal gas law. Remember, look at what you're given and what you're trying to find. When you have something afterward, that's V2 or P2, pressure or final volume. What you start out with is volume and pressure, P1, V1. Use Boyle's law. Isolate on one side the variable you're calculating or trying to find, V2. In order to that, we have to get rid of P2. So we divided this side by P2, and we divided this side by P2. And you get this, because anything divided by itself is number 1. 1 times V2 is V2. And all I've done, you don't have to, in this step, is just turn it around. V2 equal P1 times V1 over P2. Put in the numbers we find from reading the problem, do the math, and we're done. Not really. Let's do another one. Oh, let's have some fun with this. Oh, let's make it 10 points. Forgot to put the gas down there. All right, let's take a look at this. If a cylinder has 26.11 liters, L is liters, at 635 torr of air is a gas, then what is the pressure of the cylinder if the volume is reduced to 1.01 liters? So what are we trying to find? I did it again. I made another mistake. It's mess up Monday. Was the pressure if the cylinder is reduced to 1.01 liters? Well, what are you given? Or what are you trying to find? The final pressure. That's P2. After you make some changes, what is the pressure? You're given that final change is the volume. Now, I'm going to give you a couple seconds. What's the initial pressure? P1. What's the initial volume? V1. Your turn. Again, what's the initial pressure? P1. What's the initial volume? V1. All right. Well, it says if a cylinder has 26.1 L is liters, that's initial volume. And at a pressure of 635 torr. And that's the initial pressure, P1. Now, if we look here, we're dealing with a gas. That's what air is. And we're only dealing with volume, V, and pressure, P. And you should know now that's Boyle's law, P1 times V1 equals P2 times V2. What's P1, V1, P2, V2? If you look at important information, test number 3, Boyle's law, P1 times V1 equals P2 times V2. P1, initial pressure. V1, initial volume. That's where you start. P2, final pressure. V2, final volume. That's where you end up, wherever you end up, over here, whatever. And now we know we're doing Boyle's law. What are we trying to solve for? P2. We want that alone on one side. Oh no, we got to get rid of V2. Well, how do you get rid of anything that's multiplied times something else? You divide by it. Anything divided by itself equals the number 1, cancels out. And therefore, whatever you do to one side, you have to do the other side of the equation. So since I divided this side by V2 to get rid of V2, I'm going to divide that. Now, anything divided by itself equals number 1. 1 times P2 is P2. And I'm going to rewrite this. P2 equals P1 times V1 over V2. Now, I took the time to figure out what is P1, V1, and V2. So P1 is 635 torr. V1, it's up here, 26.11 liters. V2, 1.01 liters. Now, before I pick up my calculator, I'm going to use unit analysis again. Notice I have torr times liter divided by liter. Liter divided by itself, unit-wise, cancels out. And I'm left with torr. And what is torr? A pressure, which we're trying to get to, P2. So now I'll pick up my calculator. Make sure I clear it. Do the math. And my calculator gives me this number. And now I'll remember on test 3, it'll say like on test 2, please use proper significant figures for all calculated answers. So I will. This is 3 significant figures. This is, 4 significant figures. And this is 3 significant figures. And remember, when you're doing multiplication division, you get the same number of significant figures in your answer as the numbers you're multiplying and dividing that has the fewest significant figures. So how many significant figures should our answer have? I'll give you 3 seconds to figure that out. And I'll give you some more. Time's up. 3 is the lowest number. So now you need to round this off to 3 significant figures. Your turn, then I'll do it. Time's up. Keep the 1, keep the 6, keep the 4 by 3 significant figures. Use the 1 to round off. Is that 4 or less? Yep. So this is all gets dropped. And my answer is 1.64 times 10 to the 4th. And it's torr. So, oh, by the way, warning, I'm going to do some artwork. My mother was a really good amateur artist. My father was a really good amateur carver. Not one iota of that rubbed off on me. But when I do artwork, you can laugh your brains out. No, not that, but here's our piston or cylinder. Here's our initial. Now, if we take it and reduce the volume by lowering the piston, here's our final. And that's what we just did. Now, one of the questions you should be asking yourself more and more now in my class is, why am I learning this? Well, the good answer is someone told you have to take Chem 1105 or a 1-semester chemistry course, and you want to get a good grade so you can get into another program or into a college, 4-year college. But why really learn that? Let's take a look at what we just did. You have a piston and you push the plunger down, what happens to the pressure in that piston? Well, it started at 653 torr, or this number I can also write, or I'll write this right here in numeric. You started with 650 torr pressure by lowering the volume, pushing the plunger down. You've now made it up to 16,400. That's almost 20, 25, almost 30 times higher pressure. And what have we done? By lowering the piston, we've compressed the gas. And what happened to the pressure? It went way up. It got larger. Where do I do something like that? How many of you ever filled a volleyball or football or soccer ball with a bicycle tire with a hand pump? And you take it, get some air and push it. Well, there's a valve here when you push it that by pushing the plunger, just like in our cylinder, you're increasing the pressure in the hand pump. And here's an example one, the plunger you pull up, you push down, and you keep on doing that. And what you're doing is pressurizing the air in there using Boyle's law. Now, if you've ever gone to a gas station, which I now have my own compressor, but you'll see an air machine, and it's called a compressor. Why is it called a compressor? Well, in there, instead of you doing it, there's a motor that drives a piston back and forth to fill what's called a reservoir, and that has highly pressurized air. And that way you can inflate, put air in your tires. And that all follows Boyle's law. So why are you learning this stuff? Well, guess what? You use it. You just don't know about it, but now you do. All right, let's move on. Now we've done the Boyle's law practice, and we'll do some more when we do the practice problems for chapter 6 next week. Now, listen carefully. Switch is off, click. There's Charles' law. And Charles' law is the volume of a sample of a gas is directly proportional, and this is important, to the Kelvin temperature if the pressure is kept constant. This will not be on my test. See, it even says it. Charles' law will not be on any test or final exam. Now, Charles' law is V1 over T1 over V2 over T2. And V1 and T1, initial volume, initial temperature. V2, T2, initial volume, final volume, final temperature. Every time in the past when I put this on, students have trouble solving for either T2 or V2. Now, I was a math minor at a technical institute. I took all the way through partial differential equations. For me, that's a snap. But for students, what a nightmare. Most of them, so I just don't put it on the test anymore. But an example of Charles' law which deals with volume and temperature of a gas. If you have a balloon like the kind you buy for parties, and it's the dead of winter, you have your party, and you take the balloon and you go outside and tie it to your balcony or something in your backyard, a fence, and it's like 20 below that night. Next morning, you'll see the balloon, which was like this, is almost shriveled. Oh no, it leaked. Nope. It's Charles' law. The temperature went down, the volume went down. But good news, I'm not going to put it on a test. Now, wrong thing, right thing. Again, Charles' law will not be on a test or exam, so I'm not going to do any practice problems. All right, let's talk about, click switches on, vapor pressure and boiling point. And note, your instructor, me, will include some aspects of vapor pressure and boiling points that are not in your textbook. But you need to learn this. All right, let's go through some things. What happens when liquids evaporate? What's evaporation? It's the process in which molecules escape from a liquid to gas phase. If you were to put some water on a table or somewhere and come back a couple of days later, and it's just a small amount, it's gone. Where did it go? It evaporated. It went from a liquid to gas phase. Now, temperature affects evaporation. Evaporation happens at a quicker rate for hotter liquids than cooler liquids. And when evaporation, notice the note, happens, the liquid gets cooler. And I'll talk about sweating. Remember, men sweat, women perspire, and cooling towers. Now, let's do some definitions, but I won't ask on a test. But when we talk about water vapor, that's gaseous molecules of a substance, or talking about water, it'd be water, at a temperature and pressure at which it would ordinarily be a liquid or a solid. So if we talk about water vapor, say you go into your bathroom after you've taken the shower and you see the mirror all fogged up, and it's winter, or it could happen even in summer with your air conditioning on. Inside that room, the water vapor is very high. Now, the temperature in that room is below what we call the boiling point of water, but it's still a gas and we call it a vapor. Now, when we talk about vapor, we're talking about a gas, and gas has pressures. So you can have the vapor pressure of liquids because the liquid is changing to a gas. Now, there's a concept, and again, this definition and the next one I will not ask on a test, quick, but it's important to understand what I'm talking about. And here we talk about the concept of equilibrium. That's a concept in which a condition in which two opposing processes are taking place at the same time. Now, if we have evaporation, our time, watch out, you have a little water in a puddle here. Molecules of water are evaporating. And that's happening at a certain rate. But at the same time, the vapor can become a liquid. So you have things that are going from this to this and then back, and that's called an equilibrium. And it's happening at the same rate. Now, as I said earlier, vapor is a gas. And in a gas, you can measure pressure, and that's the pressure exerted by a vapor above the liquid when the liquid and vapor are in equilibrium. So if I have a glass of water or a pot of water, there's vapor being created, meaning gas, and the gas is forming a liquid. Now, when this is happening, you can measure pressure of the water vapor. So what does this all mean? And let me also throw in a volatile substance. That's a substance that readily evaporates at room temperature because it has what's called a high vapor pressure. Gasoline is a volatile substance. Water isn't that volatile. Now, let's talk about boiling and boiling points. And if this were a dial that I could turn to 10 maximum, how important this is, I've just turned it to 20, even though it only goes to 10. I stole that from the movie This is Spinal Tap. All right, now boiling is a special form of evaporation where the conversion, I'll never ask you what boiling is, but you should be familiar with it, where the conversion from a liquid state to vapor occurs within the body of a liquid through bubble formation. Well, let's keep on going. Hang in there with me. And the boiling point of a liquid is the temperature in which the vapor pressure of the liquid equals the external, meaning the atmospheric pressure exerted on a liquid. So let's say you have a pot of water. That's a pot, and you're on a hot plate. It's electric, so here's its plug. And you have water. Well, I think you've also done this either on a hot plate or on a stove. You'll see that water start to boil. What do you see? Little bubbles form, and they go to the surface and collapse. What's inside the bubbles? Water vapor. And when they come up here and collapse, they form a pressure, vapor pressure. And when the vapor pressure equals the atmospheric pressure, then if you had a thermometer in there, remember, you can laugh at my artwork big time. When the vapor pressure equals the atmospheric pressure, the temperature of the thermometer is the boiling point of that liquid. In this case, it's water. So when you measure the boiling point of water, when the vapor pressure equals the atmospheric pressure, that's the boiling point. Now, what you don't know, but I'm going to tell you right now. Now, I have in here normal boiling point when it's at 760. at sea level, well, meaning 1 atmosphere of pressure or 760 torr, by the way, this is shorthand for point, shorthand for water. And at sea level or 1 atmosphere pressure, the boiling point of water is 100 degrees C. Now, this is something you should know. And know this. When you go to higher altitudes on Earth, the atmospheric pressure reduces. And because of that, since you're at a lower atmospheric pressure at a higher altitude, and know this, at higher altitudes on our planet, the boiling point of water or any liquid is lower. And if you go to Denver, the mile high city, since it's at a higher altitude, a mile higher roughly than Chicago, the boiling point of water there is 92, not 100. And if you know people who live in Denver, and I've been there, you'll see things like rice or noodles that you cook in boiling water. They have a sticker on there that you have to cook them longer because the boiling point of water is much lower. Now, if you go to Kathmandu, if you don't know where that is, the Himalayas, if you go to the top of Mount Everest, I think that's the tallest mountain on our planet, you're at a much higher altitude, and the boiling point of water is not 100 degrees Celsius, it's 68, and that's way lower. Why? Because the altitude, at that altitude, the atmospheric pressure is much lower. Because of that, the vapor, when you boil water, it needs to be less. You need less energy. That's why the temperature is lower. With that, I'm done for today. I'll see you tomorrow. Don't forget, hand in labs tomorrow. Don't forget to have a picture when you hand in a lab. And don't forget to make sure it's a single PDF file that I can open. And with that, I'll say, Gang gesund, goodbye. I stole that from Granny of the Beverly Hillbillies. Bye.